Okay, so today actually we have to discuss our second lesson. So that is again a theoretical lesson. Let me move to the syllabus first, right? So this is related to the previous lesson. Actually, we have learned some stuff related to that in the previous lesson, but we have to further learn some other tasks in this. This is my, okay. So let's start. Okay, let's move to the syllabus. Mainly this lesson, we have to learn about the logical diagram, or we can call it von Neumann architecture. So that is basically explaining how a computer is working. In this von Neumann architecture, we are learning how computer is working. So related to the computer, what is the logical architecture? And also we have to learn components of this logical architecture. That is the that is basically about this lesson. So let me open that first. And here actually we didn't learn some fundamental things that is about this. So registers, this DRAM, SRAM, and the single core, multi-core status, and also about the ROM. And this is basically how computer works, the von Neumann architecture. I have already given this note, I can, as I remember, but anyway, so let's move to that part now. Okay. First of all, there is a theory part again, history of computing, how computer evolved, how the computer is developed. So here we are learning about some generation, first generation, second generation, third generation, fourth generation, and the fifth generation. Actually, now we are in the fifth generation, but it is future generation as well, because we have started the fifth generation, but so still we need to know about more, know more about this generation, because still some of the tasks are in the research level. So let's learn about the mechanical and electromechanical era. So this history of the computing, and also how we can categorize computers. So based on the technology, based on the purpose, based on the size. So that we have to learn here. Then we have to learn about the hardware components. So these components basically we have learned in the first chapter, but we need to know some other components like MICR, OMR, OCR like thing. Then yes, then about the other hardware device. And here, as I said, the von Neumann architecture, how logically these things are working, and the fetch execution cycle. So there will be some question from this area, from the fetch and execution cycle. I'll explain that. Then the memory hierarchy, and there will be some questions from the memory hierarchy as well. And then, okay, that is it. So after learning the memory hierarchy and after learning these memory categories, that lesson is, I think it will take 2 days to finish this lesson. So let's move to the history part today. Today we can discuss the history part as well as this technology, purpose, size-based classification. Sometimes we can move to the 2.2, but we will not be able to finish that in during today's lesson, because it has some more things to discuss. Actually, from this, they will ask very simple questions. From the today's lesson, they will ask very simple questions, but from the fetch cycle and von Neumann architecture, which will be learning next week, there will be more questions to the paper, right? Okay, so let's start. I'll give another note for this actually related to the history of the computing. So let me take okay, here it explains about the history of the computers. Right? The computer that we are discussing today, actually it has a long history, which is going back. So the clear evidence we consider, abacus is one of the clear evidence that we can find related to the computer, because abacus is a machine, kind of machine, which was used for early calculations. Still we are using abacus. Abacus is a fundamental device, but still we are using abacus for learning calculations. So this was used 5,000 years ago in ancient history. Actually, this is called zero generation. Zero generation means this time we are not categorizing these things into the generations. So we call that pre-mechanical era, before 1450. But there were very few evidences. So you can see this is abacus. This is old abacus used in Egypt. And so then in 1642, no need to actually remember the years, but so just try to remember the facts. Anyway, I'll give you this note, right? There's a person called Blaise Pascal. He invented something called Pascaline. You can see this is Pascaline machine. This machine, right, was to perform additions. Basically, he introduced to do additions and also subtractions. That is the initial Pascaline machine. It is in 1642, closer to 400 years, 350 years actually, right? 350 years ago. So this introduction was done, and it was to do the addition, and so remember that, addition and subtraction. But later this was developed to do the division and multiplication and division, but mainly it was invented as addition machine. It's called adding machine. Pascal's adding machine, no Blaise Pascal's calculator. This is mechanical, right? So it was not using any power, any current. It's mechanical. Basically, you have to rotate these wheels and do some calculations using Pascaline. Then, so there was another significant invention which happened 30 years after the Blaise Pascal's invention, that is by this Gottfried Wilhelm von Leibniz. So he has invented, he's a German scientist, and he has invented something like this. This is called punch card. So you can see this is a cardboard, but it has some holes. In this cardboard, there are some holes. These holes are used to store data, or these holes are used to input data or to output data. So it was used in many computer operations, computing operations, not computer, right? Computing means calculation. So this was used to input a pattern. This was used to output something. This was used to store something. So actually, why this Wilhelm, he has used this for, he has developed this, he has developed Pascaline for the division and multiplication, and he used punch card for feeding data. Right? So this Pascaline, you can see Pascaline, initially it was fed manual data, but with this invention, right, punch card was actually not invented by him, but he was using punch card for the Pascaline calculations. Right? Then another invention, that is Jacquard Loom. Right? Jacquard Loom is not a computer. Jacquard Loom is not a computer, but it is a weaving machine. But this weaving machine was kind of programmable. It's not actually, we cannot call that a programmable machine, but the thing is, so it was possible to feed data using punch cards. And actually what is fed, what is inserted or what is given is the pattern. According to the punch card pattern, so you can see, you know, the punch card is the card with holes, cardboard with holes. According to this cardboard with holes, you can see it is a very lengthy cardboard with holes. According to this hole pattern, the weaving pattern was decided. So then this is another thing. Actually, this punch card was invented by a person called Herman Hollerith, right? That is actually not there in my note. Yes, it is not there, right? So yeah, the punch card was invented by Herman Hollerith, right? Actually, he is considered, so he is considered as the inventor of punch card. So let's say punch here, punch card. His first experiment was punch card, right? So his first experiment, this is in 18th century, right? He was in like his experiment was with punch card, right? So he's considered, but the thing is, think about the years. Then Joseph Jacquard, for Jacquard Loom also he has used punch card. In 18th century, so this person, I hope you know the name, his name is Charles Babbage. He invented kind of engine. Sorry. So Charles Babbage, father of computing, he invented not a computer, it was engine, right? It was just engine. But this engine was leading to a computer. You can see his engine. This is called analytical engine, right? It was not a computer, but just an engine. But engine was used later. It was used for development of a computer called, so this is Mark I, Harvard Mark I. Actually, Babbage's engine was used in Harvard Mark I computer, right? Therefore, actually so why he is considered as the father of computing? He suggested the idea of input, process, output, and storage. So memory, he suggested this idea through his analytical engine. That is why, so in today's computer also we can see this input, output, process, storage, these things. Now, therefore, we consider Babbage as the father of computing. And the lady here, her name is Lady Ada Lovelace. Lady Ada Lovelace, and she has introduced a special program to work with Babbage's analytical engine. So she is considered to be the first programmer due to that reason. Actually, this is also in 1980s. Charles Babbage invented analytical engine, and Lady Ada Lovelace has developed a program to work with Babbage's analytical engine. So she is considered as the first programmer due to that reason. Okay, then you can see Harvard Mark I. This was the computer, Harvard Mark I. This was invented in 19th century. But remember, Babbage introduced his engine in 18th century, 1830. After 100 years, his engine was used in Mark I. So think, Babbage ne, Babbage ke engine එකෙන් computer එකක් හදද්දි Babbage ne. In 1940s. Actually, this was considered as dawn of computing. This period. 19th century. Actually, there is a specialty in this period. Can you remember that? What is the specialty? 19th century? 1940s, basically. Any specialty in the history? Why this period was the dawn of computing? Any reason behind that? Any world incident happened in this period? Can you remember any world incident? 1940 period. Can you hear me, Dinoja?
Yes, sir.
That is Second World War. That is Second World War. Actually, the computer, why there was a lot of development because of the Second World War. You know, our people, I don't know why, this is actually natural to mankind. Most of the time, most of the inventions are coming due to war. Right? When war is there will be a lot of inventions. So due to this Second World War, there were a lot of inventions, and computer were, right, it was rapidly developed in that period. And also the internet, not just the computer, internet was also developed. So Mark 1 was later developed into Mark 2, Mark 3, and Mark 4, likewise. And then in same time, 1950s, the first electronic computer was released. Actually, previous computer has electro and mechanical component, not just electronic. It was electronic and mechanical. But the first electronic computer is the reported first electronic, because there is again argument, right? Because this is some people are arguing ENIAC is not ENIAC is not the first electronic computer. But so officially, according to the official reports, official documents, because there are a lot of projects now. That's why they are arguing. In the World War time, secret projects were going on. They didn't publish. So people were doing researches, but they didn't publish. Right? Due to that, but this is the first published project as the first electronic computer. You can see this is a part of that. This is not the entire computer, this is just part of that. Earlier days, computers were like a large room, large garage. And then later, so here you can see approximately 5 million hands ordered joints, 5,000 calculations per second, 18,000 vacuum tubes. You can see, imagine the size, 1,500 relays, 70,000 resistors. So it is very large machine indeed, right? And then UNIVAC, EDVAC, UNIVAC, MANIAC, likewise, there were a lot of computers. And IBM also came to the market. IBM is one of the pioneer company who developed computers, international business machines. As a pioneer, developed business computers. They were also developing the computers, IBM 704. You can see this is an image of that. And this is Apple. This is Apple 1, Apple 2, I think, Apple 2. Right, Apple, this is Apple. This is also Apple computer. Apple also came to the market in late 19th century, 1974. This Altair, after that, the Apple, 1976, you can see, Apple 1. So actually, when Apple 1 was introduced, it was small computer. Unlike these large garage size computers, Apple 1, Apple 2, these were very small computers. So it was the era where most of the personal computers started evaluating. Personal computer, that means a person can own a computer, but before that, universities own computers, and maybe research centers, army, large, maybe not large organizations, large universities, they own that, but not personally. But by 1970s, so even personally, it was possible to buy a computer. So Apple 1, it was such machine, you can see, right? So it is very small computer. Then, so let's learn briefly about generations. These years can be vary source to source. Maybe in your book there will be different year, in your document, if you search Google, different years. But don't think about the years, just think about the generation number and what of the invention related to the particular generation. Right, the first generation. So it used, the technology was vacuum tube, and the machine was very, very large, garage size computers, and it was very high power consumption, high cost, and it was not a personal machine. It's not movable because it's like a building. No, building is not movable. Therefore, so the first generation computers were not movable, and mostly inputs were punch cards, and magnetic tapes were also used, and some programming languages were used. Actually, some programming language, it's machine language, right? Not programming languages introduced in the second generation. Assembly language actually. But in the initial, mainly the machine language, binary language was used. Second generation, so assembly language was there, and also some programming languages introduced that time later in this generation. And so the main technology was transistor. The first generation technology was vacuum tubes. The second generation transistors. Transistor and vacuum tube, if you compare the size, transistor was like, it was like few millimeters, but vacuum tube, it is few inches. Vacuum tube was very large. It's few inches. Anga gana loku samana adiyak vitara wenna. Loku mema, I think again. But transistors, it's like 1 centimeter, 2 centimeter maximum. Right. So it can be maximum 10 centimeters likewise. So it's centimeter, millimeter scale. Very small. Therefore, computers became smaller and smaller in the second generation. And instead of punch card, the magnetic drums, magnetic tapes, magnetic discs were used, and cost was low. But the computer was again larger in size. It was not possible to bring personal computers due to that. Assembly language, right? Rather than using machine language, the second language, which is assembly, was the main language in this generation. Assembly and machine language. In machine language, you have only 1 and 0 for coding. So all the binaries, basically, whatever you need to write, you need to write in binary, the characters, letters, pictures, everything you need to write in binary. Programs, codes, everything. But in the assembly language, a short version, something like this. More short or short version is used. That is in the second generation. When it comes to the third generation, these actually first generation, second generation computers were really in the programming were machine dependent. Machine dependent means when you write a program to first generation computer or second generation computer, it was not possible to write the same, actually use the same program in some other computer. Because computer to computer codes were different. Computer code venas. Therefore, the computer programming was not much popular. But so later with the introduction of high-level languages, this problem was solved. And you can see some images of the second generation computers. Right, these are second generation. Then comes to the third generation. Third generation technology. First generation technology was what? Vacuum tubes. Second generation, transistors. Third generation. Any idea? Third generation?
Circuits.
Sorry?
Circuits.
Yeah, integrated circuits actually. It is not circuits, not just circuit, it is integrated circuit. Circuit were used in first and second also, but this is integrated circuit, IC. Right? IC chips, integrated circuit. So IC is like hundreds of transistors together created IC. Therefore, in this generation, the computer size was really small, right? Really smaller than the first two generations because of this IC and very less power consumption, very less heat generation, and high-level languages. So you can see the computers like cabinets. But it was again not possible to bring this computer because computer like large piano. If you wish, you can bring it home, but the computer was a little larger. Still, it was larger. But later with the fourth generation, right? Later with the fourth generation, it was very large scale ICs or very large scale integration circuits or large scale integration circuits. Large scale integration or very large scale integration circuits actually use microprocessors. Those are called microprocessors. It uses several ICs into one chip. Therefore, the computer became even more smaller, portable, movable, personal computer, the idea of personal computer. That is in late 1980s. එතකොට මේවා ඇවිල්ලා ඇත්තටම අවුරුදු 30ක් විතර දැන්. Right? 1980s means around 30-40 years. Right? Sometimes not even older than your parents. Right? Less. Right? It is younger than your parents. So that is your personal computer in the fourth generation, where high-level languages were used, and right, high-level languages were used, and these were programmable, portable. It was possible to buy that and less power consumption. So it was sometimes even powered by batteries. And this is personal computer, the initial version of personal computer. Right now we are in the fifth generation. But there is no proper margin. Some people tell still we are in the fourth generation, but some are telling no, we have stopped now. We have already passed the fourth generation. Now we are in the fifth. In fifth generation, actually, its main focus is ultra large scale integration and artificial intelligence, AI. Ultra large scale integration, and not just that, artificial intelligence. So that is the third generation idea, right? So ULSI and AI. So high level languages are used, and the computers can think big, computers can think and act, computers can take decisions. So this is the last generation or the fifth generation or our future. Okay, so with that, we rapidly discuss this 2.1 generations part. It has 4 periods in the school, but I have done rapid revision, right? Okay, one more thing. That is how you can categorize the computer. How you can categorize the computer. So based on the purpose, there are special purpose computers and general purpose computers. Based on the size, super, mainframe, mini, micro, and mobile computers are there. That is based on the size and performance. So based on the technology, analog and digital computers are there. So let's learn about that quickly. Okay, please write down this. Classification of computers. First, based on the technology. Whatever we are learning here, please remember this until your networking lesson. Why I'm telling like that, in networking also you need this. Analog computers, please write analog computers under that, are using analog data and analog signals and analog signal is a signal means data at transit. which can take a value, sorry, any value between a given range, which can take any value between a given range. Then please draw this image. So here, let's say there is a comparison of amplitude over time. So let's take one side amplitude, the other side time. So any amplitude, it can take any amplitude. But there is a maximum and minimum. Between this maximum and minimum, it can take any value. Between this maximum and minimum, it can take any value. Analog data are basic facts about something, someone, or some concept which can take any value between actually for this one I can give example: sound, human, hearable, $20,000 to $20,000 hertz, right? So example for this one, you can say height, weight, length. Actually, these analog computers were using analog as the technology. So please write down and let me know once you're done. Right, in the other hand, what is digital? So digital computer is basically, so similar to this, I can write down the same thing, but there are some differences. Digital computers are using digital data and digital signals. And so you can say a digital signal is a signal which can take not any value, you can say given value between a given range. You can say given value between a given range. So given value between a given range. So it will look something like this, digital. So okay, digital. So only it's like steps, right? Digital steps only, right? Only some given values. Only some given values, some steps. You can see this is an example. It has only given values, but no need to draw this. This will be a little complex. So let me show you some. No, not good. Okay, here this has some meaningful image. Otherwise, like you have to draw everything, no? So let's this. Okay, only draw the purple color signal. Don't draw any other thing, only draw the purple color one. Again, you have amplitude and time, but you have the values are like steps. Same thing, right? Same amplitude and the time, but so no need to draw this ash color line. Silver color line shows analog signal, respective analog signal. Therefore, only draw the purple color line and the two axes. So let me draw that. These two axes as well as the purple color line is enough. This is time axis and this is amplitude axis. So no need to write digital, you can just say amplitude and time. This is time. Then the purple color line will be enough. Let me know once you're done.
Okay, sir.
Right. And so I'll write example. I'm not going to write note for digital data. Digital data are similar to this, right? Digital data keyword, it's similar to this. Digital data, let me give example for analog digital signal example. You can say a network signal. It's a digital signal, right? Then, so digital data, that is about, again, basic facts about something, some concept, which can take given value, not any value, given value between a given range. Example, you can say your grade. It can be grade 1, grade 2, grade, but not any value. So you can say another thing, only given values. You can say gears. Gears. You have gear 1, gear 2, gear 2, gear 3, 4, 5, but not gear 10, 11. So don't have such thing. Okay, please write down that as well. So that is how you divide computer according to the technology. Analog, digital, and there is another one which is hybrid. It was not mentioned in the book. Hybrid. It uses both analog and digital technologies. That is called hybrid. It uses both analog and digital technologies. Done?
No, sir.
Okay. So if I'm going to give you a big note, it will take more time. So I'll give important facts only about the second thing, but there are a lot of things to learn. But in the examination, this will not be tested in much depth. So therefore, let's learn, but only write important things. That is based on the second classification is based on the size and performance. So how you can divide according to size and performance. So number one is, you can say supercomputers. So these computers looks like large cabinets. Don't think about the cabinet in the parliament. I'm telling about the cabinet or the cupboard or kind of drawer board. So let me show this image. No need to draw this supercomputer. right? Supercomputers are, it looks here, you can see. So they basically, so these supercomputers are there as these cupboards or robots, and inside that you have the processing unit, networking unit, and all. And remember that these supercomputers are there as farms, not as individuals, because it is very difficult to maintain this, because supercomputer need to have alternative power source in case of power failure, and need to give the protection by sealing and locking, and also the fingerprint like protection. So need to consider about the room temperature, need to monitor always. Therefore, to maintain the supercomputers, mostly supercomputers farms are created. So Google on a supercomputer farm. So Huawei and so such people, they create their own farms, because then for the entire farm, they can facilitate. And they will rent out this farm, supercomputers in this farm to the other people. That is easier than individually maintaining supercomputers. So let's say, so normally a single person will not maintain a supercomputer, because this can be used by thousands of people, several hundred thousands of people. Therefore, it is not maintained by a single person. But let's say a university want to own a supercomputer, so they can buy it. That is a separate story. But the thing is, mostly what they do, they will rent it from this supercomputer farm. That is enough. No need to buy a supercomputer, because this is like the price will be millions and billions even. So no need to buy that. So you can rent out. So that will be easier. So those are there as farms. So supercomputer basically, right, can be used by several thousands of people simultaneously. Large audience can use this simultaneously. Then you have mainframes. Again, similar thing. So it is a little smaller than supercomputer. So several hundreds, maybe 900,000 people can use. Hundreds or thousands, right? Even it can be 1,000, 2,000 people. So they can use that. So much, it is a little smaller than the supercomputers. So please remember that this term is also used to identify the computers, identify the ancient computers developed in first and second generation, right? So this is something different. That is not the mainframe computers today. So, but old large computers also termed as the mainframe computers. Parana computers වලට කියනවා mainframe කියලා. මේක පටලවා ගන්න එපා. මේ classification එකේදී supercomputers කියන්නේ mainframe වලට වැඩිය, sorry, supercomputers වලට වැඩිය පොඩි එක තමයි mainframe කියන්නේ. Supercomputer එකේ මල්ලි. So you can say that it is brother of, in this generation, in the 5th generation, 4th generation, we can say the mainframe is brother of supercomputer. But the thing is, it was also used to identify computers which were ancient, which were developed in the first and second generations. So that mainframes and mainframes in the 5th generation are not the same, right? It's different. Then mini computers. Normally, workstations are considered as mini computers. So this term is also incorrectly used in the internet. If you search mini computer, you can see small computer. That is also mini computer, but this mini computer is not mini computer actually, right? Mini computer computers. This is incorrect, right? This is not the same mini computer. Sometimes when people call mini computer, this kind of computer comes to your head, but that is not the mini computer that I mean. The mini computer, what I want to mean is this. It is also looks like a cupboard or cabinet. So these are the mini computers that I'm referring, not these mini computers, right? These are also mini computers, but these mini computers belongs to the microcomputer category. Bit confusing, right? This mini computer belongs to the microcomputer category, but this mini computer is the one that I'm taking. So those are working as workstations. Mini computer, it can be workstation. So those are also mini computers, not this. So these are mini computer workstations. These are mini computer workstations. These are also some workstations, right? Mini computers. Tens or hundreds of people can use this simultaneously. Supercomputers and mainframes are used by large organizations such as Google and large universities. Mini computers, universities as servers, right? As service providing computers. Server means service providing computers. Mini computers are used by medium scale companies universities as servers or game stations. So please write down this. That is microcomputers. So I'll give the category only because no need to write down about this. Microcomputers are the computers that we use, right? So we use microcomputers. Example, you can say, so I'll give the examples, then you can easily remember the features of those things. No need to write down. Personal computers, laptops, mobile computers, so then like embedded computers, like watches and all coming under this category, right? So that is easy to remember. So those are the microcomputers. Actually, that's why I said that mini computer image in the Google, sometimes it shows image of microcomputer there. Okay, I think it is clear to you now. So this is the second categorization. The third categorization is purpose. There are according to the third categorization, right? According to the purpose. So there are two kind of computers, general purpose. Actually, that is what we use in our day-to-day life. So that is general computers. Special computers. So these are used in researchers, and not just in researchers, can be for scientific experiments, weather reporting, and medical diagnosis, for medical usage. So likewise, so these are the special computers. So maybe mining industry computers, mining industry, or maybe disaster management,
Space.
sorry,
Space.
space missions, yes, space missions. So these are special purpose computers. Not to do Word X, not to do some like Word, Excel, photo editing, not to do such tasks. These are having special tasks. So those are called special purpose computers. Okay. And with that description, I think we have come to the end of the particular part, that 4-period lesson. That's why I said if time permits, we'll go to the 2.2. But anyway, we have already discussed 2.2, but we need to discuss few things, because I'm not going to discuss what is keyboard, what is mouse, and all. We have already learned that. So let's learn about the other special input devices next day, and also output devices, and this DVD technologies like DVD, R, RW, ROM, R plus, R minus. So these things, by what these things are referring, and also the von Neumann architecture part and the memory hierarchy. This is not difficult, so that we can learn in the next day. Maximum it will take 2 days to finish that, because I'm doing as a theory class. Even though I said that I will revise the lesson, I have not skipped anything. So whatever I'm covering in the theory class, I have given to you, right? Everything I have covered. So I didn't skip anything. In revision class, actually, I don't need to do all these things. I can just remind and just give the surface knowledge, but I didn't do that. I have covered the entire lesson. So let's try our maximum to finish this by next week. But if time permits, otherwise it will maximum it will take another 2 days to finish this. And so I think you need this lesson as well, right? Lesson number 3.
Yes, sir.
3 and 4 both, or only 3?
No, sir. We did 2 no, in our theory class.
Sorry?
We are currently doing 4th lesson in our theory class, no?
Not 4th, right? Are we doing 4th or?
HTML.
Yeah. It is not 4, no?
Then 4th lesson also we have.
Yeah. So it is not 4, not 5. In the theory class, I think the HTML lesson comes here. But anyway, so in the theory class, there are some lessons to be covered. So that is basically the operating system lesson is still we have not done. Don't worry about that. We'll do that. And this lesson number 4 we have done in the theory class already. I think you missed that. So we need to do that as well due to that reason. And 5 actually we have not done. 6 is about networking. That also we have not done. Don't worry, we will cover that in the group class. So 5, 6 will be covered, and 6. This is very big lesson. 6 about networking, and 7 is about the systems. So that is also not done. So no need to worry about that. That will also be covered in the group class. 8 is about, yes, no, databases still not done. That is also not done. So no worries. And 9 is problem solving, that we have done. Because I'm doing this at the first instant. The reason is because this gives 25 marks in the paper. So you will be getting 25% marks for this lesson number 9. So that's the reason I am covering this at the initial stage, because it will give the majority of marks. This actually you missed again. You missed 2 lessons. So that this lesson and the lesson number 4. Lesson number 4 also will get closer to 12 marks, 12%. That also you miss. So I have to do then 3 and 4. But this I'll arrange another way, right? Maybe when, so I have planned to do this because there is another student who was asking this lesson. I'll arrange with him, I think that is better. Otherwise I have to do this individually, means this will take very long time. That's the reason. This will take very long time. So it is inconvenient to me and inconvenient to you as well. Because this is basically, it will take 4 months, minimum 4 months, and minimum. Maximum it will go up to 6 months. So that's the reason. Okay, I'll do arrangement for that lesson that you missed that. I'll do arrangement for that. And HTML is here. HTML I started because it is easy lesson and it is also giving you some here. It is lesson number 10. It is not skipping. I just wanted to give you some practical exposure. That's why we have started that lesson, right? And it is easy lesson. After that, MySQL connection, all these things come. With this, I will be merging lesson number 8, database. Right here, when we learn MySQL, I'll be shifting to 8 because then it is easy to understand, right? Then you will learn 10, 8, and yes, 10 and 8 both. Then I'll be moving to networking part, which is here. Yes, lesson number 6, 7, networking. Then, 6, networking and internet. Then I'll be moving to operating system. So I'm doing reverse order, but there is a reason, because I need to prepare you for the examination ultimately, right? But if you still need like how we are covering the code, so if you need the coverage according to the school requirements, school curriculum, so this won't match with that. But don't worry, anyway, according to my plan, so if even though you are doing your examination in 2023 or 22, doesn't matter, I'll be finishing this in 22, right? So I need only 1 year to finish the syllabus. I don't need 2 years to finish the syllabus, not only 1 year. That is usually I'm doing that because I don't need to drag this for 2 years, and that is boring for you and boring for me as well. And you can focus, maybe you can, so there are some students, if they want to remember, they will come to the next year class as well. And there are some students, they are doing early examinations. Within 1 year, some of them do examination now, because not like earlier days. Now people do private exams for A-levels. So they will complete without waiting 2 years. They will complete within the first year. I suggest you that is better, because like you can get the results early and enter the university, or you can think about the next thing without wasting 2 years. Give a try, but I don't know about the other subjects, but you can just give a try, because students are doing like that. That is totally up to you. Okay, that is my plan. But if you need any alteration, let me know, then I can do according to that as well. Okay, so think about that. Think about my plan as well. Think about your plan as well. And let me know what then I can do according to that. Okay, then I'll stop here. So let's see you in the Wednesday.
Okay, sir.
Okay, bye.
Thank you, sir. Good night.
Right.